Good afternoon. My presentation will also focus on production and technologies. It has three parts. First is in terms of procurement. How do we improve the quality of coking coal? And second, in terms of production, how to ensure quality. And three, a brief introduction of the coal blending technology service system in Fenwei Digital. So we will start right ahead. And this first slide is about coking coal evaluation indicators. Here are some of the major indicators as coal blenders that we use every day. Some of them are used more frequently, some less. I only list part of it. The first is impurity indicators, including ash and sulfur, and second is qualification or coal rank, which is mainly VDAF and vitrinate reflectance. And third indicator is caking and coking properties, or the plasticity and dilatation. It contains G value, plastic layer index, and Audibert anode dilatation, and geocellular fluidity, T1, T2, T3, and MX, and so on. And fourth is coal ash composition, including calcium dioxide and so on. And here, and the number 5 would be the lithotype analysis, including the standard deviation S, vitrinite reflectance and distribution, as well as optimal properties of coke. We, as blenders, use it on a daily basis. All of these indicators cannot always be included in the contract. Usually, here are some of the indicators that are commonly used in coking coal purchase contract. And when there is an undersupply, we believe that the efficiency for purchasing is more important. If the quality control system is too complex, it will impact the efficiency for purchasing. So our principle is, first of all, to maximize the quality of purchased coal with the simplest indicators. And second is the maximal control of the quality of purchased coal through correlation of different indicators. That is, to find the instabilities with the minimum amount of indicators. Here are the indicators. They seem simple, but they are logically connected. First, impurities, and second is the coal rank, which is VDAF, which is the most important indicator to judge the type of coal. And also, we are looking at the caking and coking properties, which is G and Y. 99% of the contracts are still using G and Y value, which will tell us about the quality of the coking coal.
I'm talking about coking coal. And the third indicator is caking and coking properties. And another indicator is the CSR of coke, meaning controlling ash content under other constraints. So if you have all those four indicators, you can form a framework to understand the basic quality of coal. So this is a very simple tool that you can use. The fifth indicator is about further standardizing the procurement. It's standard deviation S or reflectance range distribution. Because of the requirement of the contract, you will have different quantities and qualities of coal purchase. And then the sixth indicator is place of origin. This is also one of the quality indicators in the contract. So where does the coal come from, whether it is from Shanxi province or Inner Mongolia or from Australia? So these are the commonly seen quality indicators that we use. And now let me show you an actual contract. And this is not violating the non-disclosure agreement, because I'm only showing you part of the screenshots. And take a look at this example. The G value is larger than 80. The reflectance standard S is lower than 0.15. And take a look at the other indicators. Cohesion G is larger than 80. And take a look at the third. CSR is larger than 60%, and the standard deviation S is lower than 0.16. Sulfur is 1.3. The thermal intensity is 6.8. So this is fairly high standard. So take a look at this example. They are somewhat similar, but here we have reflectance, and that is about 3.8. So these are a couple of different contracts. Given this requirement on the market, in Shanxi we are basically featuring the mainstream mixed coking coal in our market. And the first is the G and Y value plus the standard deviation of 0.15, and the other is 0.2 of a standard deviation. And then we have another category which has no requirements in terms of a standard deviation. For vibration, there are many different values, lower than 25%. And accordingly, I have selected 4 different types of coals, 2 coking coals, and then some thin coals, and methane coals. So the price was from some time back. It may not be very indicative. The CSR is 65, and that was in 2019, and then 26, 27, 28. That is the proportion of methane coal and 1/3 of coking coal. So it's 38, 34, 28, and 20. When the proportion is between 28 to 35, it has a heat intensity of 35. So when you have 25, you could have a heat intensity of 20. So the conclusion is that volatile matter is an important constraint indicator when there is no requirement for standard deviation, and the quality of purchased coal will be reduced if there is no Y value requirement. 2.85 and 2.9 would give you a price spread of 64 yuan. So in reality, when you are working on the standard, each digit of volatile matter may generate a price difference of 10 yuan. And Y value is also very important, and it's a baseline requirement. The quality of the coal would be reduced if there is no Y value requirement, and it could be 13.2, 13.4, or 12.8. So that is why I say that the quality of coal would be reduced if there is no Y value requirement. So this is not something very sophisticated, but if you take a deep dive, you will come to this conclusion. And now let's take a look at the delivery standard for coking coal futures. Traditionally, there is no Y value requirement, but here we have the Y value requirement of 10. When the cohesion indicator is 65, the thin coal can underpin the quality of the coal. So you can see that the volatile matter has changed, the Y value has been adopted. So I also calculated the quality of the three different types of coking coal. You may ask why there is a standard deviation, because since their heat intensity is the same, 65. Well, the answer is that if there is a requirement of a standard deviation, if we're talking about coking coal, if you are a supplier, you can only select three types of three types of coal: thin coal, fat coal, and coking coal. But if there are 11 different types of coal, it would be very costly to come up with the exact configuration. And also, if there is the standard deviation requirement, can you guarantee that the coking coal can meet the quality standard? Not exactly. So this is the logic that we are talking about. For coal with a standard deviation, I have selected 13 different types of coal. As I mentioned, that you can only select one out of the three mainstream types. If, for example, you are selecting a fat coal, you cannot guarantee the standard deviation of 1/3. So you can only select amongst these three categories. And let me report to you from 0.15 to 0.2. The first is that the volatile matter is around 80. Why? Because the thin coal is cheaper than fat coal. And when you are making up this configuration, you would definitely select more cheap coals. I'm not saying this is the best configuration, but you have to understand that as the standard deviation rises, the coking coal proportion is 51%. So it's determined by what kind of coal type that you are selecting. So this means that G and Y, they are very important value for coal quality. And this price spread is 73 yuan. And the price spread for 0.206 is 117 yuan. So the conclusion I can draw here is that the restriction of standard deviation S on the content of coking coal is very strict. So if you are very concerned about the coal quality, if that is related to the settlement of the contract, you have to pay particular attention to standard deviation S. Then the second conclusion is that volatile matters and G, Y, and CSR and S still cannot fully control the quality of purchased coal. So I'm saying that even if you use standard deviation, you cannot guarantee the quality of the coal. you have to be very careful when you are settling a contract. And now let's take a look at the quality standard and requirement for futures. For 10% of volatile matter, you can either go thin or go fat, and you definitely go thin because it's much cheaper. Even at 0.2, the proportion is 70%. So this is about coking coal. For 1/3 coking coal, I'm talking about fat coal. You can see that the heat intensity is 35. So this is whether this is feasible to 1/3 of coking coal. If you put that in the contract that you want to have a coal with a heat intensity of 35, then it may not be very appropriate. So this is to just give you a context of what we're talking about. So this is the standard at the national level. The yellow marked one is 15 fat coal, 24 coated coking coal, 16 to 26 of fat coal. And if you come up with the baseline requirement using heat intensity, then there is no problem for the red colored one. This is 1/3 coking coal and methane coking coal. And if you use heat intensity to restrict the quality, then it is not appropriate. And now let's come to the production process. In the procurement process, you cannot restrict too many of the indicators, because if you do, you'd have to conduct a lot of tests in the production process and then feed back to the procurement process. So there are not so many measures to restrict the quality of the coal. And now let's talk about the evaluation of coking coal based on coking mechanism. So we have to know the usage of each component. So how does the coal get converted into coking coal? We have to use this plastic mechanism of coke making. Basically, at the very beginning, it's the quality of plastic mass, and then gas release, and then a semi-coke shrinkage. You have to allow it to vaporize, and the volatile matter is very important, and then the amount of shrinkage is also very important, because these are the three very key processes. But you have to pay particular attention to the plastic mass properties: expandability, impermeability, and thermostability, and fluidity. You need to ensure that all those four indicators are right up to the standard. And for the green-colored ones, as I mentioned earlier, this is the number 25 coking coal and number 16 and 26 of fat coal. And then let's come to 1/3 of coking coal. It has a cohesion of more than 65%, with the G value larger than 84, Y value larger than 16, and B value larger than 60. You cannot simply use heat intensity to ensure or guarantee quality. If you have a volatile matter that is below 34, then you have to focus more on how fluid the coal is. We have a volatile matter between 28 and 34. then you have to ensure volatility. So you have to pay attention to how sealed the coal is.
In terms of gas-fed coal, we mainly look at the effective plastic interval or T1, and as well as ash composition. This is the basic evaluation principle, and these are also coals that including lean coals that goes up, and the gas coal and it goes down. This is the VG map, and this can be used as a reference. The blue triangle is the lean coal. In the blue triangle, you can see that the VDAF is less than 18 to 20 or 20. So as you can see that the volatile matter or reflectance is more important in this regard, and this BDAF is less than 18 to 20, as I mentioned, and is controlled mainly by degree of metamorphism. The yellow part would be gas coal with a VDA of 28 to 37. And in this part, for gas coal with VDA 28 to 37, the volatile matter and G value have a joint effect. And when it exceeds 35 or 37, the volatility and G value have a joint effect, but volatility has a greater effect than G value. The second graph is a very classic graph that takes from the book that is published in 1960s. However, this is the reflectance. So when it is greater than 1.0, not only is the vitrinate group of good quality, but the difference between microcoal component also decreases gradually, and active inert ratio has less impact on coal strength. When the reflectance is less than 1.0, the quality of the vitrinite group deteriorates rapidly, and the differences between material components are also large. If the optimal point cannot be reached, coal strength will quickly decrease. I mentioned some principles, including the judging and evaluation standard. And last, I will be talking about Fenwei coal blending technology service system. Our company has done a lot of effort in this regard, so I've been working closely with coke-making factories and companies. I think as a coke maker, you need to focus on the following aspect. First is raw material planning that guides procurement plans. And second is inventory strategy as well as procurement strategy. And third is the coal blending technologies in order to keep the cost low. First of all, in terms of coal sourcing planning and assessment, we are at a very high level in terms of raw material allocation. We will give suggestions to the businesses. And second is inventory strategy, which gives you a clearer picture and help you to determine your inventory strategy. And third is accurate coal blending or optimization of minimum cost. I think to do those aspects well, if you can completely fulfill two tasks that I mentioned, you will gain profit with no doubt. So through our analysis, we can continue to optimize our plan by limiting the categories of the varieties of coals in order to reduce costs and improve efficiency. That's my presentation. Thank you.